So we are starting a new unit, exponential functions. This problem says a certain bacteria triples each minute and started with a single bacteria. Make a table, sketch a graph, and write the function rule. We haven't dealt with any exponential, so we're going to more of work through all three of these steps. And like I told you guys just a minute ago, I personally think that exponential is the easiest thing we do all year. Just because it's pretty simple. It does get more complicated when you get to Algebra 2, but in Algebra 1, this is just more of an introductory thing to exponential. But even in Algebra 2, I still think exponential equations are the easiest. All right, so this one is number of minutes. So we have number of minutes. Remember, we always put the process column whenever we're first looking at something to help us write the function rule. And then number of bacteria is what we're finding out. So, how many minutes have passed when you start in the very, very beginning? When I say it started with a single bacteria, have any minutes passed? No. So we always start, and make sure you always start with 0. So I start with 0 minutes. How much bacteria did I have after 0 minutes? 1, because it said single. I start with 1 bacteria, and I'm just going to draw a little picture, and it's going to be a terrible looking bacteria, but we're going to have this little circle right here. That's our bacteria. Now, it's going to triple. What does it mean to triple? If I have 1 of something and it triples, you're going to have 3. So now I have 3. Now I don't want you to draw this. This is just me talking about it. So if I have a single bacteria and it triples, I'm then going to have 3 bacteria. Now if that triples again, it's not 6. It would be 9, because each of those bacteria has to triple. Do you see that? So each of those triple. So now I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, then those are going to triple again. So how many would I have after another minute? So this is 1 minute, or this is 0 minutes after 1 minute, after 2. Now each of those are going to triple. And this is really how bacteria work. In most cases, you're going to start out with however much bacteria, then it's going to triple or double or whatever, and it's going to, each of those make new ones, and each of those make new ones, and each of those make new ones. And that's why, like, whenever you see on Lysol wipes or Clorox wipes, it's like, kills 99.9% of bacteria. That 0.1 that is left, or 0.01% that's left, is just going to keep reproducing. So you pretty much, if you want your house to stay spotless all the time, you pretty much have to clean constantly. Because the little bit of bacteria that wasn't killed by the Clorox wipes is going to just keep reproducing, or whatever. Okay, so like I said, don't draw that picture just because it's going to get really big really fast. So we said after 1 minute, this tripled. So what happened from 1? How many did it become after 1? 3. What happens from 1 to 3? When it triples, what did we do? You multiplied by what? Multiplied by 3. Okay, look at the next one. After 2 minutes. Remember, those 3 tripled. So these 3 tripled and became 9. So then it would be 9. Mathematically, how do you get from 3 to 9? Multiply by 3 again. So remember, when we did linear, it was adding by some amount each time. Exponential, it's always multiplying by the same amount each time. Okay, so what would be the next one? It would be 27 because 9 times 3 is 27. So now if we look at this picture that I drew, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So there would be 27 bacteria after the third minute. Okay, let's do one more. What's 27 times 3? It's 81. So times 3. So it is 81. So if you look on this one, for the process, we just have a 1. Does everybody agree? That's how much you started with. So you have 1. Now, after 1 minute, didn't you take that 1 and multiply by 3? Yes? How did I get it the next one? You multiplied by another 3, right? Then on the next one, you do 1 times 3 times 3 times 3. So every time it's multiplying by an extra 3. And you can type that into check. So I started with 1 bacteria, 1 times 3. I multiplied it by 3. I tripled it, multiplied by 3, multiplied by 3, multiplied by 3. So I ended up with 81. Now, do you think, or is there an easier way to write these equations? Or to write 2 3's multiplying? 3 squared. So remember, that's why we use exponents. So this would actually be written as 1 times 3 squared, because there's 2 3's multiplying. What would this one be? How many do I have? It would be 1 times 3 cubed, because there's 3 of them. And this one would be 1 times 3. How many 3's are there? 1, 2, 3, 4. Should be 3 to the 4th. Okay, this is 1 times 3 to the 1st. Now, we haven't really completely talked about exponents, but if I did 3 to the 0 power, that means you have 0 3's multiplying, so it's just 1. So that's why this just stays a 1. Okay, does everybody see that? Now, I'm going to go ahead and I'm going to show you how we write out exponential. So our equation here would be y equals 1 times 3. Now remember, when we do the process column, what is changing is what do we use? When something's changing, when we're trying to write our function rule and have y and x, where is the x going to be? Where did this 1 come from? The number of minutes. So after 1 minute, I've only multiplied it by 3. After 2 minutes, I've multiplied it 3 twice. After 3 minutes, 3 to the 3rd. After 4 minutes, 3 to the 4th. So you're going to use 1 times 3 to the x. That is our function rule. So you asked if I could do the process as I'm doing the number of bacteria. Yes, you can. Remember, the only reason we do the process column is to show, to help us get this rule. I'm about to write out the rule so that you don't have to do the process. Like, I'm going to say this goes here every single time, this goes here every single time, and that's how you get the equation. So notice, where did that 1 come from? The number of bacteria. So it's going to be, every time you write an exponential, the equation is going to be written as y equals, we call it A, which is weird, but it's A. That is our initial amount. Remember, the word initial just means how much you started with. It's also the y-intercept, because remember, the y-intercept is when x equals 0. So it's initial amount, or the y-intercept, and then times, where did this 3 come from? The number of bacteria it was multiplying by, right? It said triples. So what we call that, we call it our constant multiplier. So since it said triples, we know that it's multiplying by 3 each time. So 1 is how much we started with, the 3 is how much we're multiplying by each time, and then it's raised to the x power. Remember, your equations always have a y and an x. Okay, so let's go ahead and I just want you to write out what initial amount means. Initial amount, that is how much you started with. Or the y-intercept when x equals 0. Okay, the constant multiplier. So constant multiplier is how much you multiply by each time. You can find it if you're given a table, you can find it by taking, like if I took 9 divided by 3, what's 9 divided by 3? 3. So if it wasn't a word problem and you were only given the table, so if I gave you this table and said, what's the multiplier? You could take 9, divide by 3, and it would tell you 3 is the multiplier. So I'm going to give you, you're going to get quite a few word problems in these, but again, like I said, that's how they're basically going to look, just like that one. So if these are the common ones you're going to see. So if it says something doubles, what does that mean you're multiplying by? So you're going to multiply by 2. What if it says triples? We already did that one, but we'll go ahead and write it right here. What is triples? What are you multiplying by? 3. Quadruples. Now sometimes it will say something like it was cut in half, or it was half as many, or whatever. What does that mean you're multiplying by? So you're either multiplying by 1/2 or multiplying by 0.5. So remember, cutting something in half, don't multiply by 2 because that's going to double it. You're going to multiply by 1/2 or 0.5. If it's cut in thirds, that means you're going to multiply by 1/3 or multiply by 0.33. So these are just common ones you're going to see. All right, here we go. So then let's graph it. So what goes along the x-axis? Is it the days or the minutes or the bacteria? Number of minutes. So it would be number of minutes And then along the y-axis, it would be number of bacteria. Okay, so we know that number of minutes goes 0, 1, 2, 3, 4, 5, 6, 7, 8. We didn't go that high, but that's how high I'm going to go. Now, guys, look up here real quick before you start labeling. Notice, what's the lowest value on bacteria? 1. What's the highest value? 81. I cannot make my labels go 1, 3, 9, 27, 81. Why? It's not constant. So remember, I have to make it all the way to 81. So what should I probably go by? Tens. 10, 20, 30, 40, 50, 60, 70, 80. And it's going to look weird at first, especially if you've never seen anything with exponential before. It's going to look weird. So the first one was 1. So at 0, I started with 1. After 1 minute, there was 3, right? 3, that's probably around in there. 2 was 9. After 3 minutes, it was 27. After 4 minutes, it was at 81. What do you notice about that graph? And yes, I've had practice. I'm good at drawing through all those points. So this is what exponential look like. If you've ever heard the term, it grows exponentially, it's just going to keep getting bigger and bigger and bigger. What comes after 81, or what's 81 times 3? 243. So the next point would have been at 243. It's crazy, isn't it? I think it's crazy. Y'all might not. There are 2 types of exponential. You always have, or you have an exponential growth, just like this one. What does the word growth mean? It's getting bigger. So exponential growth is like this one. It's just going to keep getting bigger and bigger and bigger and bigger. So the constant multiplier is larger than 1. Or if you look at those ones that we just wrote out, it's doubling, it's tripling. Those are exponential growth. The other term we call it, or the other type of exponential, is exponential decay. Exponential decay is when it's decreasing. Oh, I was going to draw a picture of that. So exponential growth, it looks like this. So the constant multiplier is between 0 and 1, or is a decimal. Like it's being cut in half, it's being cut in thirds. It's going to get smaller each time.